Things that we've extended this to is also applications. You're starting to see more and more applications that are written to support our API, and a lot of times they'll ask for access or secret keys so they can access different functions within the infrastructure. And it's important that we identify what is the least privilege that that application needs, and we can create an EC2 instance role now for those applications and apply them a set of keys that meets the principle of least privilege, such that those applications don't have complete control of your infrastructure. So the other things we can do with NFA is enable NFA, right? Multi-factor authentication. It's a really good security practice. We support both hardware tokens, like you see here from Gemalto. We also support soft tokens as well. So anyone who has a smartphone effectively has a software token. So it's a really good practice to enable all of your accounts with the multi-factor authentication. That way, if somebody's account gets compromised, if they don't have a strong password, or somebody oversees their password, they still can't log in as them because they won't have the token with them. One of the other good uses for these tokens is has a compliance tie. Right? We have some functions on our API where you can MFA enable certain API calls. A good example of this is S3. We have a function in S3 called MFA delete, which means I can tag certain buckets. That means when an object is placed in that bucket, you have to have a token code to delete that object. So even if you have full administrative rights to the account, you need to also have a token code to delete those objects. So if I have certain types of data in financial records, or something that by regulation I have to store for 7 years or 5 years or whatever it is, I can place those in a bucket, enable the MFA delete, and have your compliance officer hold that token. So now, even your AWS admin who has complete control of your account can't delete those objects without the compliance officer giving an okay for that. The next layer we'll look at is security of the EC2 itself. And when we look at this, we break it up into two different perspectives. The first one is looking at the host operating system. And the host operating system is the part that we own. That's the stuff that's in our control. It's the part that runs on the physical hardware. It's what provides the virtualization layer. And again, access to any of those hosts is only through those bastion hosts, only with a defined business reason, and only with a personally identifiable SSH key. The second way to look at security on EC2 is from the perspective of the guest operating system. And the guest operating system is, again, completely in your control. We do not have the ability to log into them. We don't keep copies of. We can't reset your password for you. So if you lose your password or if you lose your SSH key, you're just going to have to recreate the instance. Right? So we can't get into those boxes at all. And for that reason, those are completely your responsibility to secure. You need to maintain the security of the operating system and the applications. There is another feature that we do have for you on EC2 security, and that is what we call a firewall layer. We refer to these as security groups. And security groups are an important function in instance isolation within EC2. Right? So first thing to keep in mind, these are mandatory. So you can't say, I don't want a firewall on this one. Right? Every instance has to have a firewall, or a security group associated with it. You get to control the rules that you put on there, and by default, we make the rules deny everything. Which means you have to affirmatively go in and open the specific ports that you need for the specific IPs that need to access those ports. And this gives you a good capability, a good platform to create the smallest attack surface for those instances as possible. In VPC, which we'll talk about in some more detail here in a minute, you also get the ability to do outbound filtering as well. So for EC2 Classic, the security group is only for inbound. In VPC, you can also do outbound filtering. And you can also control traffic for an entire subnet as well. So looking more at the instance isolation, we often get questions from customers. How do I make sure that if some bad guy ends up on the same server as me and he can't talk to my instance, and they can't communicate, or he can't try to get access to my virtual instance? And the way that we've designed our virtualized infrastructure is in such a way that all traffic from an instance must go all the way down to the physical interface and route up through a security group, regardless of where it's going. So if I'm on a box, if I'm on a physical host, and I want to talk to an instance in another availability zone, I have to go out to the physical interface.